There's so many challenges in oxygen not included, especially as you approach the mid-game. You might have heard of these solutions: the Aquatuner and Steam Turbine combo for heat management, self-powering electrolyzers for oxygen production and extra power, Atmo suits to protect your duplicants, steel and plastic to make these essential industry buildings. But we aren't playing in sandbox. How do we manage our colony properly while progressing towards these goals? That's exactly what this guide will present to you. A complete walkthrough demonstrated with an actual colony. This colony is in Terra, which is one of the most common starting planet choices. We will cover the opening basics quickly. I recommend to cut the initial sleeping time to 1 block, because even with a short sleeping time, the dupes will still continue to sleep until their stamina is completely replenished, but they will oversleep if the sleep time is too long. Set up at least 2 different schedules, so to reduce the number of duplicants, using outhouse or lavatory at the same time. Disable this auto-disinfect, because this is a completely meaningless action which only wastes your time. Set the priority. Digger, researcher, builder will prioritize digging, researching, and building respectively. Set 1 or 2 dupes to slightly prioritize life support, which includes delivering to important buildings like oxygen diffusers, outhouses, or water sieves. There's no need to ban duplicants from every other job types. You can just leave them as is. We have pretty much summed up the initial settings. When you are ready to start working, here's a list of initial goals to work on. This list might look really normal to you, but you won't always be playing on an ideal world generation. If you can't finish everything in the first cycle, don't stress about it. The only thing that really needs to be completed in cycle 1 is a functioning outhouse, and all other things in this list can wait for a few cycles. Outhouses are the most important because the consequences of duplicants making a mess can be really annoying. There are a lot of reasons why pea water underground is bad, but the worst is that the duplicants will likely get the chilly surroundings debuff when they step on it, getting a -5 athletics penalty, effectively cutting their moving speed in half. They will also give 10% of stress per cycle, on top of another 10% from soggy feet. In comparison, duplicants sleeping on the ground would only get -1 athletics from soreback instead of 5. Having no wash basin might result in food poisoning, which makes the duplicants pee more than once per cycle, as well as -30% stamina per cycle. It's kind of bad, but still not as close as chilly surroundings, and some dupes could get away without washing hands, since it's a random event instead of guaranteed. If you are the type of player that rush lavatories as soon as possible, I would say ignoring the wash basin at the start isn't a ridiculous choice. Oxygen diffusers are not urgent either, because the oxalite and free oxygen at the start should support the duplicants for more than 3 cycles. We're only looking to dig briefly, so we have enough dirt and metal ore to construct the initial buildings. It can be tempting to send duplicants to dig every time you are unsure of how to proceed, because digging is a really simple process and can be executed even without preparing. But especially in the early game, I would not recommend overdigging without a specific reason, because that really doesn't make any progress to the colony, even if it looks so. My water pool is quite large and conveniently close, so I have put down wash basins to go with outhouses and enclose it to make a latrine room. But, as mentioned earlier, if you can't find a comfortable place for wash basins or latrine, it's fine to just drop random outhouses, ignore the other buildings, and just quickly renovate to plumbed washrooms. Latrine is just 1 morale, and the duplicants are unlikely to need any morale at this early stage of game anyway, since they don't even have skill point to spend. When placing digging orders, it's important to make sure the duplicants will not be trapped, especially in unbreathable environments. For example, at this moment, I have ladder building and underwater digging orders going on at the same time. If the digger went underwater and dug all the tiles before the ladders are finished, it could be trapped underwater and suffocate. I would recommend to keep an eye on the risky working zones, so you can react as soon as anything goes wrong. Alternatively, you could just play safe and place the ladder order first, and only place the digging order after the ladders are finished, so there is no risk of being stuck at any moment. Next decision to make is the placement of research stations. You might know about a tip to place 2 research stations right next to the printing pod to take advantage of the light buff from the pod and to make the room into a laboratory to further boost the researching speed. But I would say the laboratory is just optional. If we look into the numbers, each point of science attribute gives a 40% boost to the duplicants, So a starter science dupe with 9 points would have a 360% research speed boost. On the other hand, Lit Workspace and Laboratory gives 15% and 10% boost respectively. They are additive instead of multiplicative, so they are really insignificant compared to 360%. You might be thinking, every speed boost counts, and 10% is still better than 0, but researching speed is not the only factor. The science station requires dirt to operate, and if the printing pod is too far from dirt patches, the researcher would be often pending on dirt delivery. Therefore, I suggest to just put the research stations at the nearest convenient big dirt tiles to cut the delivering time. You could always add your own light source to give those two boosts later if you want. A ceiling light only costs 10 watts to operate. Here's the first few techs to research. Power regulation tech to unlock the jumbo battery, so we have a larger power buffer than small batteries. Meal preparation tech to unlock farm tiles and mess tables. After these researches are done, we can start planting mealwood as our main early food source. Each mealwood provides 200 kilocalories per cycle, and a normal dupe requires 1000 per cycle. Therefore, we need about 5 plants per dupe to satisfy their food requirements. But this early on, it's unlikely we have 15 mealwood seed to go with the 3 dupes we have. The seed will propagate over time after being harvested, but initially, we need to dig to find more seeds to kickstart. When there is a crack sign on a natural tile, it implies there is a buried object hidden inside. In the starting sandstone biome, we can not only find mealwood seeds, but also muck roots, which is a quick food source. For the initial 5 cycles, we could send a digger to dig out areas where buried objects are dense, until we have roughly enough seeds to plant the number of mealwood we want. The rest of early game infrastructure is straightforward. Build cots and barracks, dig to find more seeds and finish the mealwood farm, build an oxygen diffuser, set up mess tables to make a mess hall, and later convert into Great Hall. As I mentioned, these are not super urgent, just take your time and complete them with your pace. The printing pod will make the first offer halfway through cycle 3. We are looking to increase the crew size to 6, but if the first offer doesn't look good, you could always reject or take care packages and wait for a better offer after 3 cycles. For this guide, we are not going to use any rancher or cooking skills, so these can be ignored unless you are doing achievement runs which requires ranching. For now, a second researcher, an operator, or a supplier dupe all works fine. Just take a dupe without major drawbacks such as unconstructive, anemic, flatulent, narcoleptic, or trypophobia. With these basic infrastructure completed, we are ready to prepare for mid-game. This might be a shock to you because it's only cycle 5. But let's analyze the colony a bit to confirm that we are in a good position to start the mid-game transition already. About food, we are completely relying on mealwood, and the dirt requirement is not sustainable. However, there are hundreds of tons of dirt on initial world generation, and this amount of dirt can feed a reasonable crew size of 6 to 8 for hundreds of cycles. We have enough time to work on alternative food source after the mid-game transition is done. About oxygen, the oxygen diffuser requires algae, and it might run out faster than dirt, but self-powering electrolyzers is part of the mid-game plan, so this is exactly what we are going to work on. About heat management, there is actually no imminent heating issues in the early game, and the Aquatuner and Steam Turbine combo we are going to build is also exactly dealing with this issue. About morale, with a great hall and barracks and downtime, we would have about 8 to 10 morale, and that is enough for the first 100 cycles, since the dupes won't have that much skill point to spend yet. About power, with the oxygen diffuser and research stations being the only power consumers, we shouldn't have much power consumption in the early game, and manual generators should be sufficient at this point. You might be wondering about coal generators. They can be helpful in the early game, but it is also fine to play without using it. If you were to utilize it, be sure to automate it with smart battery to prevent significant fuel waste. It's not regarded as a good late-game power source, and I would not recommend to spend effort trying to make a sustainable coal production setup. There are many better late-game power options, and in this video, we would cover hydrogen and petroleum as part of the mid-game transition. But on top of creating new power sources, it's more important to not waste power. One of the most common mistakes that wastes significant power in the early game is to use gas pumps just for air circulation. For example, pumping oxygen from one room into another connected room like this. The oxygen would diffuse downwards naturally, but in this example, The rate is really slow due to bad air circulation. The correct solution is to leave a wider gap between walls so the air would circulate much better, and this prevents the gas pump usage completely. Gas pumps are really power hungry, and most of the time, they should not be used without a good reason, such as pumping into a building or pumping out from a SPOM room. With all these survival aspects analyzed, let's start focusing on our mid-game goals. The first two things we can start with is reed fiber for Atmo suits and gold ammogram to build pumps in hot environments, such as crude oil or inside a SPOM. Fortunately, both of these things can be found in the marsh biome. To explore out of the starter biome, we would likely have to dig through granite, which requires the hard digging skill. But it is also about this stage, around cycle 6 to 7, the starter dupes would have collected enough experience to get the first skill point. This timing is really nice for the digger to start digging granite and the researcher to be able to access the supercomputer. There might be multiple marsh biomes located at different directions, but I would recommend to dig towards the bottom, because later on we would be going for the crude oil on the planet core anyway. Marsh biomes are quite close to home and usually oxygenated, so exploring there shouldn't be a challenge, except for one thing that might concern you, which is slime. If you have played Oxygen Not Included many years ago, you might have the impression of colonies being destroyed by slime lung. However, after a patch, it was seriously nerfed, and slime lung is no longer fatal in the current version. You could choose to just ignore the slime completely and dig straight past it into the marsh biome, since the consequences are not really serious, but it might not be very informative if we just conclude like this. So let's look at an alternative approach to avoid contact with slime lung. The natural slime tiles contain a lot of slime lung germs, but they will not start spreading until we dig them out. We can check the material overlay to easily track the location of all the slime tiles. If we are able to reach our target without digging any slime tiles, then this would be trivially easy. If not, we can take advantage of the fact that slime debris will not off-gas when submerged under at least 1800 grams per tile of liquid or gas. For example, these two slime tiles would be immediately submerged after being dug. These two tiles would fall into the pool below and be submerged. These two tiles would not fall directly, but if we dig out the two algae tiles below them first, then they could fall into the pool directly after being dug. With some observation and planning, a lot of the slime tiles could be removed without any risk of spreading their germs. But don't get carried away and try to dig out every tile in this biome. Our current goal is to just clear out a passage so the dupe can access the thimble reeds. Clearing every single tile has no benefit besides OCD satisfaction, and we can wait until we have established a stable base for that. Similarly, these polluted water pools are actually quite helpful by keeping the slime germs from spreading. There is no need to drain these polluted water or relocate them into some artificial storages for now. As we approach the thimble reeds, usually we can see that the wild reeds are growing naturally. Reeds grow really fast as a plant. They produce one reed fiber every 8 cycles when wild and every 2 cycles when domesticated. If you can find at least 3 to 4 natural reed plants, I would say it's sufficient to just relying on the fiber generated from wild reed plants. If you still want to grow more of them domesticated, one reed would be enough because they consume a huge amount of polluted water at 160 kilograms per cycle. We don't need an industrial amount of reeds at the early game, but just enough to make a few Atmo suits so the duplicants can enter the oil biome safely later. It's gonna take some time for the reeds to grow. We could just mark them as enable harvest and leave them there. Meanwhile, we can start digging towards the bottom of the planet to find oil and lead. When we're digging downwards, there are two main concerns we should worry about, which is breathability and environmental hazard. Let's start with the breathability issue. It's more concerning when digging downwards compared to any other directions, because the carbon dioxide will sink and tend to accumulate in the pit where the duplicants are currently digging. But initially, the carbon dioxide amount shouldn't be much, especially if you start the digging early enough. There's also some natural air packets that could consist of oxygen, which can be very handy for the diggers. Those free oxygen packets won't be replenished though, so seize the chance and dig as further as you can before the oxygen is consumed. On the other hand, there are some unfavorable packets that may contain chlorine or hydrogen, and these gas would cause eye irritation to the duplicants, which slows them down. You might have seen people trying to seal those gas packets with a liquid lock, or to delete those gas from outside with building tiles diagonally. But most of the time, we don't have to deal with these annoyances at all. If you have noticed, my downward ladder shaft is not in a single straight line, but separated into multiple shorter segments. The rerouting is to prevent digging into unfavorable gas packets and take advantage of the free breathable air packets. Yes, polluted oxygen is not a problem at all in this context, but a helpful resource to us. It might spawn close to slime, but as we explained earlier, as long as we don't directly dig out the slime tiles, no slime lung germ will be spread into the air, and we can always start a new ladder shaft if it's needed in order to not run into slime tiles. So why not have the entire ladder shaft in a single long straight line? It appears to make the base much neater and allow the duplicants to work more efficiently. Well, a single long ladder looking neat is probably true, but being more efficient? Not really. If you ever tried to observe the duplicants while they're climbing ladders, you might have seen them dropping the resources they are carrying. This can happen because they are out of oxygen and need to gasp for air, starving, or having a full bladder. But even if all of these problems are taken care of, they would inevitably drop their stuff when downtime or bedtime hits. The longer the ladder length, the more likely this will happen while they're still on the ladder, and the drawback would be more significant since they'll have to recollect the dropped resource from a longer distance. Therefore, it doesn't really worth to aim for the entire ladder to be on a single straight line, at least in the early game. Just start a new ladder on a nearby different column whenever you need to bypass unfavorable gas packets, unsafe areas, or undiggable areas. It's gonna take quite a while to reach the oil biome on the bottom. Since not all of your duplicants would be digging, this is a nice timing to do some side projects during this period. Upgrade your mess hall room to Great Hall if you haven't, by placing a disabled water cooler and a flower pot with a decorative plant. Enclose some areas that the dupes have a chance to pass that have at least 4 natural plants to make a natural reserve. It's pretty much free of cost if you have preserved enough wild plants and did not dig out everything, which is also why I do not suggest digging for no reason. One more thing you can do is to upgrade the outhouses to lavatories, or further upgrading them to self-looping lavatories. There are many possible designs depending on if the system releases surplus water or polluted water. If polluted water is the surplus, you can feed it to a domesticated thimble reed. They are really water thirsty, and one reed can take care of the pee water from many duplicants. If water is chosen to be the surplus, you can use a liquid reservoir to hold the surplus, which is my choice in this colony. It's not a permanent solution, but a single reservoir can hold 5 tons of liquid, which will cover you for about 100 cycles. You'll have plenty of time to switch to other permanent solutions, such as sending the water to plants or electrolyzing. All of these things I just mentioned are not mandatory. Your colony wouldn't fail just because you didn't upgrade outhouses to lavatories. But these setups have a really easy cost compared to their benefits. For Great Hall and Natural Reserve, it's the 6 morale. For lavatories, it's not about the 1 extra morale, but the save time from not having to clean outhouses. There is no need to rush for these, but it's nice to do these upgrades whenever you have some spare time. Another thing you can do is to add fire poles along with the ladders as you dig deeper. Duplicants can move really fast when descending on fire poles, and that would be quite helpful as we will be going back and forth many times until the oil biome is reached and set up properly. While waiting for the digging team to reach the core, you should also start researching the essential technologies that are needed for our mid-game setup. Here's a general research order for your reference: electrolyzer, hydrogen generator, smart battery, conductive wires, improved ventilation which unlocks Atmo sensors, insulated tiles, metal refinery, Atmo suit, Aquatuner, Polymer press, and basic radiation research so we can unlock and build a steam turbine. There's no need to memorize which technology is required for which buildings. You could type in a keyword in the research tree, and the game will filter out the corresponding research needed for that building. Although there's some natural oxygen packets that could help you during the digging process, you will still run out of oxygen at the bottom at some point, unless you got a super lucky world generation. We have to provide oxygen for our diggers, both for their safety and efficiency. You might think it's safer to start digging downwards only when they have Atmo suits to put on, but that not only delays the entire working plan, and also slows down the duplicants significantly. This is because Atmo suits gives a -6 athletics penalty to the duplicants. At early game, when the duplicants still have low athletic stats, a 6-point penalty is indeed a major drawback. I would suggest to only start using the Atmo suits near the border of oil biome, where scalding may happen. So, how should we supply oxygen for the diggers? There's actually quite a few simple solutions. If you have a SPOM already running, you could just branch out the pipes and send some of the oxygen downwards and release it with a vent near your working zone. But if not, you could just build a new oxygen diffuser down under to produce oxygen. It might seem tedious to stretch your power wires towards the bottom, but if we think about it, eventually we will need power to run the pumps and other machines when we reach the oil biome, so we would need to supply power down there later on anyway. We're getting close to the oil biome. It can't hurt to mention again, the polluted oxygen and polluted water is a helpful asset to help the duplicants breath in remote areas. For this particular terrain, the non-slime tile gap is only 1 tile high, so the duplicants can't pass without digging out slime. But a 1 tile high gap is enough to allow the polluted oxygen to leak and create a free breathing zone for the duplicants. And here we are! Diamonds, oil reservoirs, lead, crude oil, all the valuable resources are waiting for us. It's possible to enter the oil biome without scalding your dupes. I have did it in my solo great escape run by draining polluted water into the biome to make it a temporary cool and safe area to work in. Even if the dupes would get scalded, their wounds can be recovered with a triage cot as long as they get out in time. But for this guide, we will take the safest way and go in with full protection from Atmo suits. Atmo suits require reed fiber and refined metal to craft. We already have some reed fiber in stockpile, thanks to the early exploration that revealed those wild reeds. For refined metals, you could obtain them with the rock crusher. It's kind of wasteful because it only converts half the metal ore into refined metals, but it's okay to use it as a temporary measure in the early game. There's not much detail we can talk about rock crushers though, so I want to demonstrate the way to use an early metal refinery. A complete and efficient metal refinery setup requires a steam turbine to extract and convert the heat from smelting metals into power. But a steam turbine is a bit deep in the research tree and requires plastic on top of refined metals. There is no need to insist on a full refinery setup initially. We can use a workaround to start smelting from scratch so we don't get stuck in an infinite loop. The setup is made with the most basic wire and manual generators. The metal refinery requires 1200 watts to operate, so using basic wire will result in circuit overloading. But as a temporary setup, this is totally fine. It will take a few refining operations for the wire to break, and it only costs 2.5 kilograms of metal to repair each time. The amount of metal wasted would be way less than if you use a rock crusher. You could manually deconstruct and reconstruct broken wires to completely avoid the repair cost, or research heavy watt wires to prevent the overloading in the first place. But I don't find it really necessary to save a few kilograms of metal ore. I also suggest to start an independent power grid for the refinery, so the overloading wouldn't happen somewhere random in the base and cause unexpected power outage. Another concern about refinery smelting is the hot coolant liquid it outputs. We don't have the steam turbine to deal with it properly yet, but we can simply dump it into a liquid reservoir. A liquid reservoir can hold 5 tons of liquid, which is enough to produce 1200 kilograms of refined metals. Liquid inside reservoir is reasonably insulated and wouldn't leak much heat, so you could just leave the liquid there until you have a good way to deal with it. For example, if water is used as the coolant, the hot water can later be sent into electrolyzers. If you do want more early metal refining, simply use more liquid reservoirs. While you are smelting the metal, you should be already researching for SPOM-related buildings such as hydrogen generators, electrolyzer, smart battery, Atmo sensors, and also Atmo suits in the same time. We can now prepare to build our first SPOM, which stands for Self-Powering Oxygen Machine. There are multiple popular designs you can find on the internet, for example, the series of Rodriguez SPOM. I would recommend to just start with a quasi version, which can support up to 8 duplicates. Don't build the largest full version thinking that is preparing for the future in advance. It's just a waste of dupe labor and materials at this stage. If you printed more duplicates later, just build more copies of semi or quasi, they're easier to manage. For the quasi version, here's a detailed design that you can refer to. The key of the design is the presence of these two tiles covered in liquid, which will allow us to automatically sort the hydrogen and oxygen coming out from the electrolyzers once the system is stabilized. When building this quasi version, you could place the build order of all the walls at once, except for leaving 2 entrances at both floors. An important thing to notice is it's better to build the electrolyzers and the gas pumps from gold amalgam or steel to avoid overheating. Gold amalgam is fine as long as you are on the planet type that has it. The Atmo sensors in the build require refined metals which you should have already smelted. The entire power usage in a quasi-Rodriguez is less than 1000 watts, so it's fine to just use the basic wire. But this setup is supposed to be permanent, so we do not want circuit overloading to happen inside the sealed room. It's gonna be a pain if we need to break in to fix the wires once the gas piles up inside the room. Also, the self-powering property would be messed up once the setup is connected to other external power consumers. So please make sure that your SPOM has its own independent power grid. Once the tiles on the top floor are completed, we can dump a little water onto the 2 tiles stated on the design that require water. It can be done easily by finding a bottle of water, clicking the relocate button to move the bottle to where you want, and click empty to release the water inside. Remember to mop the excess water on other tiles if necessary. If you don't have water bottles already available, you could create one by mopping shallow water, or order water to be displayed on a pedestal and then remove it from the pedestal to create a 1 kilogram bottle. When all the buildings, pipes, wire, and automation has been set up, and the water has been dumped onto the 2 correct tiles, we can now build the final insulated tiles and seal the room completely. Set up hydrogen generator automated with a smart battery, and we can start the system by sending water into the electrolyzer. Initially, we have to briefly connect the wire from the sealed room to our base power grid to kickstart the system, because there's no hydrogen to run the generator yet. After we have collected a few pipes of hydrogen, disconnect it from the base power grid and connect to the hydrogen generator and form an independent power grid. Initially, the gas are not properly sorted yet, and some oxygen might get into the hydrogen line and cause wrong element damage. This is totally fine and expected. Spend a few kilograms of metal to repair it, just like the Kickstart metal refinery setup I have introduced. After a while, only hydrogen would be left on the top, and if the Atmo sensors are set properly, the gas should be filtered naturally and no more wrong element damage will happen. You can also store the initial unsorted gas into a canister filler if you like, or wait until there's only hydrogen on the top part to start the pumps, as per the design instructions. Now that the SPOM is completed and running, it's time to forge and set up the Atmo suits. We don't really need an Atmo suit for every duplicate at this stage. Just 2 or 3 suits placed at the entrance of oil biome is fine. We also have to supply oxygen and power at the bottom to operate the Atmo suit docks. For oxygen, just extend the output oxygen pipe from your SPOM directly towards the bottom. Don't pump it out to your base and collect it with another pump, as double pumping is a huge waste of power. You could also use a canister filler and drainer combo to deliver the oxygen bottles without long pipes, but that will require frequent duplicate labor. For power, you could run wires all the way to the bottom, or alternatively, run another gas pipe to the bottom and use excess hydrogen to run a new hydrogen generator there. Atmo suit docks don't really draw a lot of power in average, so the excess hydrogen from your SPOM should be able to handle it. You should use proper gas bridge priority to make sure the hydrogen generator of your SPOM always gets enough hydrogen first before sending the excess towards the bottom. Other options include running a coal generator with smart battery at the bottom, or use metal power banks if you have the bionic booster pack. Both of these solutions will require duplicate delivery. If you are not confident with all of these alternatives, just run a long wire from your base power grid towards the bottom. there might be unbreathable areas between your base and the bottom. Since we already have an oxygen pipe running down, you could place some strategic vent on critical spots to release some oxygen and help the workers to breathe. As long as you don't collect them back again with a pump, opening up multiple vents do not cost any extra power. After the Atmo suit dock setup is completed, we can prepare to go in the oil biome, as well as researching towards the next stage, going for plastic, iron, steel, and steam turbine. Steam turbines require radiation research since the spaced out DLC though, so we will go through that later as well. You might be worried about these generators, batteries, and refinery placement. Shouldn't they be insulated in a separate industry area? That's not really necessary. In the long run, if we have a proper cooling solution, which we are going to get, they could be placed anywhere. If there's no cooling solution, they will just overheat if well insulated anyway. One thing you can do is to simply not place them too close to your plants, so you can have more time to set up your cooling loop before the plants get too hot. But other than that, you don't need a huge wall of insulated tiles to start using these industrial machinery. Now that we have set up Atmo suits, it's generally safe to explore the oil biome, but we have to make sure the duplicants don't get trapped and unable to get back to base. Also, prevent digging too close to magma if that's present on your planet type. There's a mechanic in the game called flaking which can instantly boil liquid that touches hot solid. This includes abyssalite, which might seem completely insulated, but actually not. So make sure to not dig too deep and expose hot abyssalite tiles. The first good thing we can find is lead metal, which can be identified as these yellow tiles when you select metal in the material overlay. They are free but inferior refined metals. They have a low melting point and a penalty of overheating temperature when used as building material. So it's best to use them as wires on most places that isn't hot enough to melt it, and buildings that doesn't care about the reduced overheating temperature. If you are on Terra, you would find this geode somewhere close to your base which also has some lead in it. But the important part is the uranium ore, marked by green in the overlay. They are radioactive when in tiles, but the radiation amount is negligible and non-radioactive after being dug out, so there is no need to worry about getting close or digging them out. The uranium ore will be very handy later when we do radiation research for steam turbine. Another critical element for steam turbine is the crude oil found in the oil biome. Not only we can refine them to petroleum and then to plastic, but also we need them later as a refinery coolant in a proper refinery setup. The oil is often hotter than 75 degrees and would overheat a pump, but using gold amalgam can handle up to 125 degrees, which should be good enough most of the time. But the most important material that brings us to the mid-game is steel. Making steel requires iron, refined carbon, and lime. Lime can be made in the rock crusher by crushing fossil or egg shells. Fossil can be found in the oil biome or in the ocean biome that has poke shells and salt water. Refined carbon can be made in the kiln from coal or wood. We can just continue to use our temporary refinery setup to refine iron and steel. Build more reservoirs to hold the hot output if necessary. Don't worry, we will renovate to the permanent setup soon. It's time to make the researcher learn the applied science research skill and set up the radiation research. The material study terminal requires quite a few refined metals. We can just use the free lead we have found in the oil biome for this purpose. There are 3 reasonably efficient basic ways to produce rad bolts for the research. Wheezeworts, manual rad bolt generator using enriched uranium, and radiation lamps. Note that I do not suggest using manual rad bolt generator with uranium ore. It's way too time-consuming and inefficient. Enriched uranium requires betas to refine them, and it's not always available conveniently early on. My personal suggestion is to use the radiation lamp if you have the uranium ore. The most important factor of using the rad bolt generator is a stable power supply. If the rad bolt generator shuts down due to no power, its stored rad bolt will decay rapidly. This means a frequently flickering power grid will result in significant power waste and low rad bolt production. It used to be also important to have a sufficiently high radiation source to prevent wasting power and time running the rad bolt generator. But since a recent update, The generator now consumes power proportional to its rad bolt collection rate when the rate is below 100 volts per cycle. So if you're not confident providing a stable power supply, it's probably fine to use a slightly lower radiation source. If you have accumulated a large amount of hydrogen already, you could run the research on a hydrogen generator. But if not, you could ask 2 or 3 duplicant to run hamster wheels with high priority to supply the power. We are only doing one single research that requires radiation, which is the steam turbine, so a quick temporary solution is really nice here. Here I am using a layout with 4 radiation lamps with 1 rad bolt generator. Feel free to try your own design, but do note the lamps can only emit radiation sideways and needs to be mounted against a tile. The automation is simple. Connect the top right port of the research terminal to the rad bolt generators and lamps with a NOT gate. This means that when the terminal is full of rad bolts, the entire rad bolt system would shut down to prevent wasting power. By default, the rad bolt generator shoots its rad bolt when it accumulates 50 rad bolts. This setting is not good, and I suggest to change it to 52 or 102. The reason is, the rad bolt will always decay slightly while traveling, so a rad bolt that is exactly 50 would end up being something like 48 bolts when it reaches the terminal. 2 such rad bolts would deliver about 98 bolts inside the terminal. Since a terminal can hold exactly 100, it will not report itself full, and the next bolt will shoot again, resulting in a huge overshoot, wasting almost an entire bolt. By reprogramming it to shoot at 52, you would only overshoot by about 1 bolt instead of the entire 50, and the terminal will be full, pausing the system until the researcher used up the stored bolts. Also, be sure to adjust the direction of all rad bolt generators and reflectors, and check the path indeed goes into the terminal. Another thing to watch out is to not allow the dupes to travel to anywhere that the rad bolt would pass. If a rad bolt hits the duplicants, not only the duplicant would be wounded, but also the entire resource and power spent on that bolt is wasted. You can use a combination of door permission, tiles, or auto sweepers to achieve this. For this run, I have blocked the top floor that the rad bolt would travel with a tile. Since the dupes cannot pass through a gap 1 tile high, they will never travel that way. The delivery labor could be done from the bottom, which is completely safe from rad bolt collision. Finally, if your duplicants don't run the wheel often enough to power the rad bolt system, you can temporarily change their job priority to operating to finish this one single critical research smoothly. This specific design generates 225 rad bolt per cycle, and the steam turbine research requires 200. So, basically, 2 duplicants running a wheel for about an entire cycle is sufficient to generate enough rad bolts to finish the research. Back to our refinery. We still need to refine a lot of iron and steel, so I'm building more reservoirs to hold the hot coolant. And since we have some refined metals to spare, you can renovate this power grid to conductive wires to stop the circuit overloading. The next step is to make petroleum. You might have heard of petroleum boiler designs that are much more efficient, but at this stage, we just have to use the simple and traditional oil refinery. Find a random area to place the refinery, preferably near the suited areas, and we can start refining oil. The oil refinery would generate natural gas as a byproduct while refining crude oil. A common way to contain the natural gas is to use a liquid airlock to prevent them from escaping. For example, a little drip of liquid here completely blocks the gas flow. This is the popular way to deal with gas. But if you think this is kind of an exploit, you could just allow the gas to escape and collect them into canisters with a gas pump. The refinery would also stop functioning when the air pressure exceeds 5 kg per tile. Depending on your playing style and preference, you could pump the gas out to canisters or reservoirs, burn them in natural gas generators, use other designs that prevent the building from going over pressure by submerging them in stacked liquid, or dig out more tiles in the room to temporarily solve the overpressure issue. The rest is simple. We only need a duplicant to operate the refinery, crude oil in, petroleum out. The petroleum will be sent to a polymer press to be made into plastics. You could add a reservoir in between as a buffer to hold the petroleum. The polymer press generates carbon dioxide and steam as byproduct. Carbon dioxide requires a gas pipe to vent out, but the steam is directly released into the environment. We don't have to really worry about the heat from the steam since it's just a little amount. But it can be handy to just place the polymer press above water so the steam naturally condenses and fall into the water pool. If the polymer press overheats, try dumping a layer of liquid on its floor so heat can be conducted faster. And now, we have the plastic production going. This means we now have the ability to produce all the critical materials we need. We can work on the last two important modules, using the steam turbine to extract heat from a permanent metal refinery setup and from the Aquatuner base cooling loop. For the metal refinery setup, you can refer to either of these two designs. Both are sustainable and permanent, but the left one will need some extra time for the turbine to extract all the heat from smelting, and the metal refining work will have to pause occasionally. In this video, we will go with the design on the right. It requires 3 turbines and a much larger footprint, but it supports 100% uptime for using the refinery. The module can be really built anywhere you feel convenient, as long as you can allocate enough space for it. First, clear enough room to fit 3 turbines, and build the top floor with insulated tiles. Then we clear the bottom floor. It's better if you build the bottom tiles after all the random debris has dropped out from the room. Debris left in the room not only trigger your OCD, but if you ever want to access them later, you are creating a problem for yourself by not cleaning them out in advance. If you're digging more than 2 rows of tiles at a time, make sure to monitor their progress, so you can react in time if they ever get trapped. The next step is to remove the random gas from the room, which is supposed to be filled with water or steam later. If it's all carbon dioxide in it, it's not a big deal. But any amount of oxygen or hydrogen in the room will be very annoying, as they are lighter than steam and will stay at the ceiling, which blocks the steam turbine from extracting steam properly. We can do this with a liquid airlock, similar to how we prevent the natural gas from escaping when refining oil. Seal the entrance with 1 drop of liquid, then pump the gas out until the room becomes vacuum. The gas pump is no longer needed afterwards, and you should deconstruct them to retrieve the materials before the room is sealed. Let's talk about the plumbing. The output water from steam turbine will be directly dumped back into the room that will be sealed later, so the amount of steam in the room stays constant. The metal refinery plumbing is a self-loop. Coolant liquid that leaves the output of refinery will go into the steam room and dump its heat onto the steam, and then leave the room, re-enter the refinery to be used again. We want as much heat dumped into the steam room, and as little heat leaked to the outside as possible. Therefore, we should use insulated pipes outside the steam room, and use radiant pipe inside the room for the refinery loop. There isn't an exact answer to the amount of water, or steam, needed in the room, but around 50 to 100 kilograms of water per tile should work fine. Dumping more water doesn't really improve anything, except for having more water stuck in the room. And you should definitely not have over 1,000 kilograms per tile of water in the room, as that will make the liquid vent overpressure and inoperable. There is also no need to spam temp shift plates in the room. Actually, you don't need a single one of them. This design is already good enough to efficiently extract the heat from smelting metals and convert to power. Temp shift plates in this design also don't improve anything. They will just end up wasting building materials, and the system will take even more time to start recycling the heat, since the plates will have to be heated up as well. This thermosensor is meant to automate the metal refinery and shut it down when the steam is too hot, because there would be some energy loss if the turbines suck in steam that is over 200 degrees. You might notice there is an Aquatuner in the design, but it isn't included in this steam room. This is because Aquatuners in the steam room require steel, and I haven't smelted 1200 kilograms of steel to build this Aquatuner yet. In fact, I plan to stop using the temporary workaround we built earlier, and use this steam room to continue smelting the steel. This is because the Aquatuner cooling loop is actually an independent module. It's essential for the colony, but it doesn't have to be exactly in this refinery steam room. We can start a new room with the steam turbine and Aquatuner combo to serve as the cooling loop. It's a bit easier to explain when we separate them. Speaking of the Aquatuner, I want to talk about the liquid choice in the loop because it is extremely important. Crude oil or petroleum should be used in the metal refinery loop, while water or polluted water should be used in the Aquatuner cooling loop. They are not interchangeable because the mechanics behind these two modules are completely different. The coolant in the refinery loop merely serves as a heat exchange medium. No matter which type of liquid we use, the metal refinery always produces the same amount of heat and dump them onto the coolant liquid. Therefore, the coolant needs to have a sufficiently high boiling point so it can stay in the liquid state after being heated in the refinery. Crude oil or petroleum is good for this purpose because their boiling point is about 400 degrees or more. On the other hand, water or polluted water cannot be used for this mission at all, because their boiling point is lower than the minimum operating temperature of the steam turbine, which is 125 degrees. They would boil and damage the pipe before they can be hot enough to pass the heat to the steam room. The Aquatuner loop is another story. The Aquatuner work by spending a fixed amount of energy to take the heat from the liquid piped into it and transfer that heat to itself. Each packet of liquid piped into it will be cooled by exactly 14 degrees, regardless of the specific heat capacity or the amount of the liquid. Therefore, except for really rare cases, it makes no sense to use less than 10 kilograms of liquid per packet. The efficiency is also proportional to the SHC, or specific heat capacity of the liquid. Water and polluted water have the highest SHC out of the common liquid types, and that's why they are the recommended liquid to go in the Aquatuner cooling loop. Later in the game, you can use nuclear waste or supercoolant, since they have an even much higher SHC and efficiency. Another issue is freezing. Aquatuners will not respect the freezing point of the liquid. If they are given the chance, they would simply freeze the liquid and damage the pipe. Therefore, liquid type with a wider temperature range is more versatile. For example, polluted water has a lower freezing point and a higher boiling point than water. Since they have a similar heat capacity, using polluted water is always better than using water. It's tempting to use oil at sub-zero temperatures, where polluted water would freeze, but remember, SHC is directly proportional to the efficiency. Crude oil and petro has a low heat capacity, and using them as Aquatuner coolant would waste significant power. For this application, we can use ethanol, which has a better SHC and even lower freezing point. If you own the Frosty Planet pack, nectar is even much better choice. And of course, once you have the ability to make supercoolant, they are the ultimate coolant choice. As a summary, just pick the liquid type for Aquatuner coolant with the highest SHC that would not freeze in your target temperature. With the help of our first steam room, we have successfully smelted 1200 kilograms of steel, and we can now build the permanent cooling loop. The cooling loop mostly consists of a steel aquatuner inside a steam room with a steam turbine on it. Except for a smaller room size, the steam room and turbine is just the same as the one in the metal refinery loop, with 50 to 100 kilograms of water per tile in it. The plumbing for the aquatuner is probably the most complicated. We need a liquid pipe thermosensor, not a thermosensor, so we can automate the aquatuner to pause working when the liquid already reached a desired temperature. The sensor has to be placed on the pipe exactly just before the input of the aquatuner. If you place it any farther, the liquid packet that enters the aquatuner will be different from the packet detected by the sensor. But there's more. If one liquid packet is coming out from the aquatuner output and another packet bypasses the aquatuner because it is already too cold, the packets would experience a traffic jam. And even worse, if the entire pipe system is now completely filled with liquid packets, the liquid would completely stop moving and the cooling loop will come to a halt. To prevent this from happening, we need a bridge buffer design so the pipe flow would be smooth even when liquid exits from the aquatuner output and bypasses the aquatuner in the same time. This is how the plumbing looked like near the aquatuner. It's a bit hard to read due to the overlapping bridges, but you can refer to this image. These four ways shown in the image is basically the same design with different orientation, and the one I am actually using is the second one. This part on the right shows the piping when we move the two bridges up for clarity reason. It is important to make sure that these two tiles aren't connected. Also, the white and blue color in this image is merely meant to differentiate the input from the output line. In practice, all the pipes inside the steam room should be insulated pipes. The double bridge buffer design automatically prevents overfilling if the pipe is filled before the aquatuner is connected to power and start running. But if you later want to extend the loop and fill in more liquid, or if you somehow overfilled anyway, you could easily fix it by extracting 1 or 2 packets of liquid from the loop with an outward bridge, which will draw the packet away from the loop. Once the overfilled packet is removed, the cooling loop will resume running smoothly. So where should you apply the cooling? You don't really have to snake the cooling loop around your entire base. The rule of thumb is to only apply the cooling to places that are really in need. Usually, plants are the most sensitive to temperature. For example, mealwood and bristle blossom, the two most basic plants, cannot grow above 30 degrees. So we usually apply the cooling loop to the farming areas via radiant pipes, so it can stay in a stable and comfortable temperature for the plants. What about the industrial areas and living quarters? It depends. There is no need to keep everything in your base cool. If nothing is overheating, and nobody is complaining about toasty surroundings or scalding, then they don't necessarily need cooling. You could apply a mild cooling on those areas by using regular granite pipes instead of radiant pipes. If anything turns out to be a real problem later, you can still switch to radiant pipes. But the most important part is, don't apply cooling to water, especially a large pool of water. If you happen to find water geyser or steam vents, it might be tempting to cool their water output as they come out really hot from the geyser. But that is extremely wasteful and meaningless. For example, the most common long-term water consumer is the electrolyzer, which converts water to oxygen and hydrogen. No matter how cool the input water is, the output gas would always be at least as hot as 70 degrees. This means cooling electrolyzer water below 70 degrees is just completely counterproductive and nonsense, because all the power spent cooling would be simply wasted doing nothing. But what if the water is hotter than 70 degrees? Because the SHC of hydrogen and oxygen are both lower than the SHC of water, the electrolyzer is actually deleting heat for you when it receives water hotter than 70. Therefore, there is still absolutely no reason to cool the input water. If your living quarters get hot due to electrolyzing, just apply the cooling directly to your living quarters. If your plants get too hot, just apply the cooling directly to your plants. Similarly, when water is consumed by supercomputer or other sources, heat is often automatically deleted in the process. It might sound a bit counterintuitive, but in this game, trying to cool from the root is much worse and inefficient than cooling something only when it gets hot. By cycle 64, we already have everything we promised that are essential for the mid-game. A SPOM to generate oxygen and power, Atmo suits, a permanent metal refinery setup, and a permanent cooling loop setup. How much power would all these mid-game modules cost? The SPOM, by definition, is self-powering and even generates excess power. The permanent metal refinery setup can recycle the heat from smelting metal, and for smelting steel, we would actually recycle more power than the consumption of the metal refinery. This means that smelting steel is actually power positive. As your duplicants levels up their machinery stats, they can finish the smelting process in less time and consuming less power. When they have about 10 machinery, smelting every kind of metal, except maybe gold and mercury, would be power positive. The cooling loop module is the only one that would sure be consuming power. At 1200 watts, the Aquatuner appears to be very power hungry at first glance. But the Aquatuner is actually very powerful at its job, and most of the time, it does not need to work at 100% uptime to provide sufficient cooling. It will likely run for a longer uptime when you first built it, but in a base without massive heavy industry, an Aquatuner usually only runs at about 20 to 40% of the time. If your starter base has an Aquatuner running forever, most likely you are doing something wrong. Either the pipes of the cooling loop inside the steam room wasn't insulated, or you are cooling something you shouldn't have. For example, cooling a pool full of hot water. Considering the steam turbine would recycle almost half the power the Aquatuner has spent, the Aquatuner would likely just consume about 100 to 300 watts on average. That can be afforded by one single duplicant running on the wheel, or by the excess power from the SPOM. What can we do beyond this point? We can continue to find more lead in the oil biome, which would be really handy, and keep smelting more steel since they are strictly better than iron, and remember, smelting steel is power positive. Pump more oil and refine to petroleum, and maybe reshape some terrain that blocks the airflow. Build more Atmo suit docks so more dupes can go in oil biome at same time. And replace regular wires with lead conductive wires. It's really soothing to watch the wires being replaced quickly. Replace some tiles with metal tiles. This one is optional though, mostly for decorative purpose and for your own sanity. Check out all these green areas in Decor Overlay. But you can just skip this one if renovating tiles doesn't mean much to you. The most important mission for now is to search out for useful geysers, especially those that produces water or polluted water. If you see a shape with 4 neutronium tiles in a row like this, it implies a geyser is buried there. Using the temperature overlay allows you to quickly locate such patterns, because neutronium is considered to be at absolute zero, so it will be shown in blue. If you click the star map button and check your home planet, it will also show the types of some geysers to you, although there might be more that are hidden. If you order a yellow alert on the hidden geyser, the yellow alert would give away the type of the geyser in the tooltip. This is a little trick if you don't mind using, but if you don't feel like doing this, the geysers would only activate when this tile on the second column of the neutronium tiles is dug out, so we can just dig out the most corner tile and see what kind of geyser it is, without any risk of triggering a dangerous geyser. It turns out to be a polluted water vent, which is very helpful for the colony. It outputs at a comfortable 30 degrees, and all you have to do is to sieve it to get easy fresh water. Don't worry about the food poisoning germ it has. As long as you cook the food you grow from plants, the germ doesn't do anything. And electrolyzing sieved water from this vent is also completely safe, as food poisoning germ is harmless when airborne. Other helpful vents include the water vent, which outputs clean water at 95 degrees. And if you remember what we talked about cooling earlier, you should not cool this water, but use the hot water as is to electrolyze, and only cool whichever part of your base that gets hot. There's also saltwater geyser, which requires power for desalination, and cool slush geysers that requires a little heating before the cold polluted water can be sieved without freezing, but also serves as free cooling source. If you happen to keep a reasonable duplicate count, and you find enough geysers that produces water or polluted water, you can consider switching to bristle blossom for food. If cooked into gristleberry in an electric grill, it requires 3 bristle plant to feed 1 duplicate, which is equivalent to 60 kilograms of water per cycle per duplicate. And duplicants relying on electrolyzer for oxygen requires about 68 kilograms of water per cycle to breath. Since we have just completed our permanent cooling setup, this means, if your geysers are able to provide about at least 130 kilograms of water per cycle, multiplied by your current duplicant count, congratulations! You now have a sustainable base with heat, oxygen, food all resolved. After this, you can consider ranching, exploring space with rockets, getting space materials like super coolant and thermium, find even more geysers and utilize them, go for big achievements like Home Sweet Home or The Great Escape, or maybe relax a bit and decorate the base as you wish. But one thing I definitely do not recommend is building an industrial sauna, which is to put your industrial production building inside a big steam room. It appears brilliant and are used by quite a few famous YouTubers, but there's a serious flaw in these kind of design which makes them actually literally worse than nothing. This means that they are wasting more power than just using aquatuners to actively cool these buildings. Explaining this in detail would worth a video of its own. A one-sentence summary would be, the materials used in the production buildings would steal the heat from the steam room and waste more power than the power saved from the industrial sauna. If you are interested to know more about this, let me know in the comments below. Anyway, back to the video. To summarize how to get a sustainable base smoothly, I would say, first, focus on critical builds like working towards the metal refinery or steam turbine, not OCD or decorative jobs at your early game. Second, don't be afraid to use good temporary workarounds if they help you renovate to sustainable builds sooner. Third, know which builds are really needed and which are not. For example, a good electrolyzer system and permanent cooling system is very important long term, while digging out your entire planet or infinitely storing everything doesn't really help, especially in the early game. Finally, don't overprint duplicates that you cannot handle until you are prepared to support more. 4 to 8 at early game is a comfortable number for me. If you are interested in playing the same map as me, I have provided the seed number and save files in Google Drive in the comments. It includes Cycle 1, Cycle 10, where we finished dealing with early oxygen and food and started digging. Cycle 41, where we have finished the SPOM and started radiation research. Cycle 66, where the refinery and cooling modules are all completed. But don't get me wrong, this video is not meant to be speedrunning, but a build order guide. Most planet starts in oxygen not included aren't really that harsh. You don't have to match the exact timing and can follow with your own pace. Even if it takes double or triple the time to complete these modules, nothing is wrong with it. See you in the next video.